Up till now, we have studied the amplitude modulations in the part 1 of the amplitude modulation part 1. We have taken the amplitude modulation with full carrier. So today we will find out the expression for the modulation factor and so on. So we start with the single tone modulation. In single tone modulation, we consider the message signal as a sinusoidal signal. So we consider a modulating wave mt equals to am cos of omega mt. The carrier wave Ct is given as AC cos of omega Ct. Then we have the modulating wave, which is the multiplication of the modulating wave and the carrier wave, gives us AC bracket 1 plus mu cos omega mt bracket close cos of omega Ct, where mu is defined as modulation factor, or we also define as the percentage modulation. This means how much percentage we are able to achieve. To avoid the overmodulation, the modulus of the modulation factor should be less than 1. If the modulation factor modulus of modulation factor is greater than 1, then we have the overlapping and phase reversal problem. So which we are not able to reconstruct the wave at the receiver side. Now we will study about the envelope of ST. The ST, which is the modulated wave, it is given as AC 1 plus mu cos of omega mt. Taking the look at the following figure on the next slide, we can have it as this. This we define as the envelope. So this is a sinusoidal wave in which the modulation factor is less than 1, and we define this as the amplitude modulated wave. This gives the envelope of the message signal, and this at the center wave is the carrier wave. So what we have done is we have changed the we have changed the modulating carrier wave with respect to the modulating wave. So we have this Vm equals to m times of Vc, where Vm is the voltage of the modulating wave and Vc is the amplitude of the carrier wave. So looking at the figure, we have this Vm plus Vm. Look at this over here, Vm plus Vm, that is given as Vmax minus Vminimum. So from this equation, we have got Vm equals to Vmax minus V minimum divided by 2. Then we find out Vc from this figure can be calculated as Vmax minus Vm. So this we are having this as the Vc. So this is given as Vmax minus Vm. So using this value, we put the value of Vm equals to Vmax minus V minimum divided by 2 in this equation. So what we have got is Vc equals to Vmax minus V minimum divided by 2, and on solving this we get Vc equals to Vmax plus V minimum upon 2. So using this formula that Vm equals to m times of Vc, we got m equals to the ratio of Vm by Vc, putting the value of Vm and Vc, which gives us m equals to Vmax minus V minimum upon Vmax plus V minimum, and that is defined as the modulation factor defined over here. In this following the slides, what we have done is we have finded out the Vmax upon V minimum. Using that equation, we have got a mu equals to Vmax A max minus A minimum upon A max plus A minimum, where the in this slide again we are having the same value. In most of the books it is defined as m equals to ratio of Vm by Vc, Vmax minus V minimum upon Vmax plus V minimum. Now we'll find out the power of the single tone modulated M wave. Here single tone modulated wave is basically a sinusoidal signal. What we have done is we have taken a carrier signal A cos omega ct as the amplitude modulated wave, that is by a single tail modulating signal xt equals to Vm cos of omega mt. Then the unmodulated or the carrier power Pc is defined as the mean square value, or that is given as the average square value of AC cos of omega ct, that is given by AC square by 2. And from the circuit analysis, we already know that the average value or the value of the mean square value it get given as SE square by 2. Then we calculate the sideband power. Sideband power PS is the sideband power. It is given as half of m square t eh, average value. So this again solving it we get is 1 by 4 Vm square using this equation 7. Now what we have is the total modulated power. The total modulated power is the power containing the sidebands and containing the carrier. In the AM modulated wave, what we have is we have the two sidebands and the carrier. So we have defined as PT, the total modulated power. It is given as PC plus PS, that is equals to SC square by 2 plus 1 by 4 Vm square. So calculating this using the formula Vm upon VC, that is MA, give us PT equals to SC square by 2 1 plus 1 by 2 MA square. Out of this, AC square by 2 is the carrier power. So using this we have defined as this equation PT equals to PC 1 plus M square by 2. So this is what we have to conclude in this stage in the amplitude modulation part 2. Thank you.